All right, so I added more binary games. I told you a while ago I'd have more of these, and now I've got them here. I put them in as a separate project. And so there's going to be modular arithmetic and advanced modular arithmetic and XOR, which are more binary things that you folks ought to know and understand, although I made it extra credit. All right, so let's talk about modular arithmetic. We've already been using it a bit, and in particular for that project where you're combining bus routes, modular arithmetic is very helpful. You should get used to it. So, here's how modular arithmetic works. You work on a ring. So you have a ring that might go from 0 to 8, and that's it. All the numbers you have are from 0 to 8. Anything else, it's like a clock. So if you take 0 and you add 1, you get 1. If you add 2, you get to 3. If you add 4, you get to 7. If you add 1, you get to 8. And if you add 1 to 8, you're back to 0. You just go around and around the ring. This is extremely important for many, many mathematical operations and computing functions. For example, cryptography. If I'm encrypting a file, I have a series of bytes, and I want to encrypt them, but I don't want 1 byte to turn into 4 bytes and get much longer. That would be difficult to handle and unnecessary, so you work on a ring. The numbers go from 0 to 255, and you perform mathematical operations on the ring, which converts it to another byte, but it doesn't leave the ring. The answer is always between 0 and 255. So this is referred to as a ring with mod 9 because there are 9 symbols here, starting at 0. And this is what you write mod 9. So 9 mod 9 is 0. This is 9, and 10 mod 9, you can get there by 8 plus 2, that gets you to 1. And so that's what it looks like. And one way to express this mathematically is when you take a number modulus something, you divide by this and keep the remainder. So 3 mod 9, you divide by 9, you'll get 0 with a remainder of 3. 13 mod 9, you divide by 9, you'll get 9 with a remainder of 4. And the only part you keep is the remainder. That's how you do this. So there's, for example, here's the higher numbers in mod 9. 18 is 2 complete circles around, so it's still mod 0. 27 is 3 times around, that's still mod 0. So 28 is 1 because it's 1 after a multiple of 9. 28 divided by 9 is 3 with a remainder of 1. That's the mathematical way to do it. You could also do it by just sort of imagining yourself walking around and around this circle. And you can have negative numbers too. Just go the other way. So minus 1 is 8, minus 2 is 7, minus 3 is 6. Might seem a little screwy, but it's the same logic. You can go backwards or forwards, but you always stay on the ring. So this could 0 minus 1, so that takes you to 8. And all right. So you can now do mathematical operations. You can add numbers mod 9. So 0 plus 1 mod 9 is 1. 1 plus 5 mod 9 is 6. Because now I could either combine this in here and get 6 and then do a mod 9, or I could apply the mod separately to each term and it would be the same. So 8 plus 3 mod 9 is going to be 11 mod 9, so that's 2. 15 plus 13 mod 9, you could do it by first doing the math inside here, so you get 28 mod 9, and that's 27 plus 1, so it's 3 9s plus 1, so it's 1, but you could also apply the mod separately to each term, 15 mod 9 plus 13 mod 9. This will give you 6, and this will give you 4, so then you have 10 mod 9. That's going to get you the same place. All right. And you can do subtraction. 7 minus 2 mod 9 is 5. 16 minus 5. You can do the 16 minus 5 and get 11, then do mod 9, that turns into 2. You could also do it separately. 16 mod 9 minus 5 mod 9. 16 mod 9 is 7, you'll get 7 minus 5. Again, you get 2. These are all equal ways to get to the same answer. Yeah?
So, in 7 minus 5 mod 9 equals 2, why do we need the mod 9?
Oh, well, you have to state, I'm doing arithmetic modulus something. Normally we do arithmetic on an infinite number line, so numbers can get as big or small as they need to. But when you choose to do modular arithmetic, you're doing math on a ring. And like I say, use it for certain applications, like cryptography and other ones, and queues and stuff, like you make a circular list we talked about before. This is just another way to do math. And it turns out to be great importance to do it this way. But yeah, normally somebody has to tell you you're going to do modular arithmetic and what the modulus is. There's no particular special thing about 9. You can do mod anything. And so here, for example, is mod 4. 0, 1, 2, and 3 is all you have. So 4 mod 4 is 0, 12 mod 4 is 0, 13 mod 4 is 1, because it's 3 4s plus 1. So that's the basics of modular arithmetic. And let's try some challenges here. There's an extra credit thing. We'll do a few of these here. You can get a flag here and turn it in for some extra coins. But let's try this. So what's 28 mod 8? That's right, it's 4. And why?
Because that's the remainder.
That's the remainder, right? It's 3 8s, which is 24, plus 4 more. So it's 4. Now let me check if there's comments in the Twitch. Are there other mods? Yes, no, that's right. Just someone asked the same question. Good. Yep, you can have mod anything you want. Any integer anyway. Any positive integer. I've never heard of a fractional mod or a negative mod, but you can have any positive integer in there above 0. All right, how about 38 mod 19? What's that? That's 0, right? That's 2 times 19 plus nothing, so it's 0. 5 mod 6? What's that?
1.
No, it's not 1. I know what you're thinking. It's minus 1, if you're going to do it that way. But that's not the canonical number. Anybody got it? 5 mod 6? Yeah, 5, right? Because it's 0 6s plus 5. It's 5. Now, 6 mod 5 is 1, but 5 mod 6 is 5. Now let's go see if there's anything on the Twitch. Yeah, good. People are calling the right answers there. Good. All right. Try another one of these. What's 80 mod 9? You got it? Yep. I see you got hand signals. You got 8. Any? All right. How did you do it?
Well, it's 9 times 8, there'd be 8 left over.
Right. 72 plus 8. That's one way. I also cheat. It's 81 would be 0, so it's one below that. But that's fine. There are many ways to do it. This is the amount left over is 8. All right, I think we can do one more here. I think you have to, let me check, you have to get 10 in a row to win, to say that. Yep, so supposedly I can do another one without handing out the flag. What's 89 mod 11? Here, 8?
Well, that's 1, isn't it?
1, right? Because it's 88 plus 1. And 88 is 811, so the remainder is 1. That's 1. All right, let's see what the Twitch people have. Yep, Twitch people are getting it right. Good, glad to see it. All right, so that's fine. That's all I wanted to give you in the way of math today. A little bit of math every class is much better than going too much. So you get to practice this till you understand modulus, and we'll do other things another time. So let me stop that.